Okay, so let's get started. That is, we continue with the summary of the uh, fundamental topics, and that is we want to know how the vectors are being um, used. So in the last two classes, we started with methods of triangle and parallelogram to combine vectors or subtract them. And today we continue with that. I think in the second um, session, we went through the Cartesian coordinates. So when you have to deal with a number of vectors, there are more than two, it is more reasonable to um, just do that by Cartesian coordinates. Okay, so let me see where we are. Okay, at last. So we continue with the Cartesian coordinate in 3 dimensions. And the main reason we started with the unit vector, because unit vector is shared between the position vector and the force vector. So whenever you want to describe a force vector, the chances are you only have measured the magnitude of the force. I mean, you only have the magnitude of the force, but how do you find the position of the force, the direction of the force? Okay, so let's assume that the force is resting against the cable, is being exerted by a cable. So any 2 points from that cable is enough to find the unit vector of that position vector. All right, so today we um, continue with using a position vector for finding the unit vector, second using that unit vector to describe the system of forces. So if you can define system of 3 dimensional forces, no matter how many they are, it becomes easy to add them together, to multiply them together, right? So imagine you have F1, F2, F3. If you have their components, you can do anything with them. You can add them, subtract them, you can multiply them, or find the angle between them. So this seems to be something very important. So please pay attention. So in a very special case, you could have the coordinate system at 0, 0, 0, but this in reality is not always the case. Because I told you the coordinate system is something arbitrary. You can choose the coordinate system in a way that it suits you, but that's a most simple case. If you are measuring the position of a point from the center, the vector is easy, x, y, k. But in most of the cases, both a starting point, end point, they are not at the coordinate, they are different points. So how do we do this? You have to remember that is the coordinates of the um, this is the coordinate. We are talking about the a. Okay, so that is b minus a, b minus a, and yeah, this is not the easiest way of doing that. I give you some other way, and this is you just choose a path to go from A to B. How do you go from A to B? It's not a unique way. I mean, I can go from, let me demonstrate this to you. What do I mean by that? If I want to go from A to B, I can go from here to here and then here, there. That's one path. The other path is I can go from here to there, and then here you decide how you construct your position vector, and then forget about that end minus the beginning. We do something case by case. So this is quite the case. You have a antenna, and that antenna is being secured by a number of cables. This is a fully three-dimensional cases. So you want to know that whether these forces can keep the antenna in the equilibrium. So how do you add the forces? How do you make sure it's in equilibrium? You need to express them in three-dimensional case. So for every cable, there is a position vector. So this is a position vector from A to B, and that position vector, we call this R. What about the unit vector? The unit vector is the parent. It is shared between the position vector and the force, which is developed inside the cable. In simple terms, if you have direction cosines, alpha, beta, gamma, you can construct the unit vector. Or if you have the position vector and if you have its magnitude, just normalize the position vector. By normalizing, I mean divide the vector by its magnitude. That gives you the unit vector. So this is another way of finding unit vector. So how do we find them? Few different ways. So you can start from the position vector, normalize it. You might be given the alpha, beta, gamma. Only two of them is enough. If you have two, the third one you can find. And this is your first example. I want everyone to grab a piece of paper and try to find out the position vector of AB. All right, so we do that together, but do you want to give it a go first? I give you 2 minutes, and then we do that together. Yeah, this is quite strange. I'm trying to work it out. All right, so let's do this quickly. Not a problem at all. All right, so I want to choose a scenario to go from A to B. And all I need is just by looking into the dimensions. Let me show you, I mean, my way. You can differently. So that is, I'm choosing a different color. So to go from A to B, first I travel 1 meter in the X direction, and then
Where the Y?
yeah, just then I go vertically 3 meters, and then I go along the Y by another 2 meters, and then in negative x, I travel 2 meters. And sorry, this should be from here.
So can I ask a question?
Yes.
Sir, how do you find that is 2?
How do I find 2?
Yeah.
That is this 2. That's 2.
This 2 is for B, right?
Yes. You want to go from A to B, right? So take a very complex path to show you that, look, this doesn't matter. If you go from A to B, no matter how, you get the same answer. So the first one is what? This is minus I, correct? So I'm writing this like so. AB, that is minus I. And then I go 3K plus, and then this is 2J, right? And then that is minus 2I again, and finally that is 3K. Everyone follows what we did? Okay, so let's simplify that. This is going to be minus 3I, and only one J is here, that's 2J, but K, 3K, 3K, that's 6K. Okay. All right. So that is the vector. How do I find its unit vector? The unit vector, I have to normalize it, and that is AB, the magnitude. That is root of 9 plus 4 plus 6. Okay, and then that is 36. Yes, thank you for that. All right, and then you just this is, you have a calculator, that is 13, 7. That's going to be 7. So unit vector of AB is minus 3 over 7 I plus 2 over 7 J plus 6 over 7 K. All right, and then that is cos alpha is equal to minus 3 over 7. Cos beta is 2 over 7, and cos gamma is 6 over 7. So you can find the angles by inverse cos.
So can we do it by taking the position of A and position of B?
Yes, you can do it that way. I quickly show you how that is works. So you can write A, the coordinate of A, that is 1, 0, minus 3. Yeah, and B is what? B is minus 2 plus 2 and 3. And then you do n minus tail, that give you the same.
Is it a way so then we can find that you take this one is minus 1, right? And we could take it plus 1. So how to do it?
No, you are going in the opposite direction of x. When you go in this direction, that's minus 1.
How do you know they're going up?
Because this is positive, right? So this is, if you go that direction, this is positive. You go that direction, is negative.
So
That
always right is like
yeah, this is positive x, this is positive y, this is positive z. If you go parallel to that, this is positive. If you go opposite to that, this is negative. All right, let's go to page 76.
In our country, used to use this sign for I. Is it needed, or you can use this?
Sign for I. Yeah, that's okay. You can leave it like I, or put something hat on top of it, arrow on top of it. It's a different conventions in different techniques. That's okay. Let's go to page 76 and see what we have there. So that is your worksheet. Page 76. Yeah. All right. So which one do you want me to solve, or solve it together? Let's try ABC. What about doing B? Huh? Yeah, medium. This is medium. Yes. Magnitude. Yes. That has to get the unit vector, because the vector itself could be tall, short. You want to normalize it. To normalize that to unit vector to the parent, you have to divide it by the magnitude. Angles won't change. This is like you are stretching it or compressing it. Not direction doesn't change. The sense doesn't change. Only it becomes unit length. Normalized to unit length. All right, so here we want to write position vector of AB. So I do that quickly because there are many things to take for today. So A to B, like I said, there is not a unique way. My choice is to go from here to there, and then from here to here, and from here to here. Finally, like so. I mean, you could do this the way that Shah suggested, writing the coordinate of A, coordinate of B, and then taking that of B minus A. But I think that's something inventive. So that is minus 3K, and then you go in the positive direction of Y, that is plus 4J, and then that is positive X, this is 1 plus 3, that is 4I, and that's it. Okay, so 4I, 4J, minus 3K.
So always you need to take from the midpoint, right?
You go from A to B, and what about it?
So you are taking the distance from midpoint.
Yeah. I mean, you could do this in a different sequence, but I just made this visually easy to follow. So that is the magnitude of AB. That is 9 plus 16 plus 16, which is root 43, is it? 32, 41. Okay, so the unit vector would be minus 3 over 41K. Sorry?
How about that, a 4J? Can you explain again?
Explain again. Okay, I want to go from A to B. So first I go this way, and then I go this way, and then I come here, and then I come here.
So that's going to be like another 4J.
Another 4K, is it?
Yeah.
Well, we did a minus 3K to begin with,
Yeah.
and then everything I think remains on the XY plane. You don't move from XY plane. Yep. So to get here, it is still on the XY. What? Where is another 4K?
4J.
4J.
Yeah.
Yes. You're right. Thank you for that. So that's 4. This is 4j first, and then another 4j second. So that is going to be 8. This is 4i plus 8j minus 3k, correct? Okay, so that makes this a little different. This is 64. So
17.
64. Hello.
You're having problems.
Someone
with the
else
phone?
called. They had difficulty using the system. I'm using
Yeah.
my own.
Using
I
that
managed to
one?
do it.
Yeah.
He had hard
Oh,
time.
okay, so you've just come in here after. Yeah.
Yeah, I can answer.
Okay, no worries. So I'll have to look at a break and come and have a look at it.
Yeah, thank
No
you.
worries, mate.
No worries. So that is
89.
64 plus 16 plus 9, 89. Still, that's not a perfect root, 89. I think we keep it as it is. So that could be 1 over 89 root multiplied by 4i 8j minus 3k. And if you want to find out the direction cosine, cos alpha is 4 over root 89. And then so let me just run through this quickly. We have too many things to solve. 2-6. All right, so the next one is page 77. Okay, page 77. Do you want something simple, medium, difficult? Barnaby? Medium. Yeah, yeah, that I like it more. So let's go with 220. Okay, so here the problem not only wants you the position vector of AB, also it wants you angle of theta. So anyone can tell me how do we find theta?
By taking this 2 by 2 is 1, 10 45 degrees.
Well, that's one way of doing it. Yes, that's one way. Well, you need to make a triangle, don't you? First, you have to project AB on that plane, and then whatever the projection is. Oh no, that's a 3-dimensional angle. You can calculate it like so. So maybe you have to find a thing here. I think what you need is that. I mean, this is not a standard way of doing that, but this is a shortcut. If you want to find theta, just solve this triangle. You have to find that green line. Once you find the length of green, this is another right angle triangle. So in that you can find theta. But if you want to follow the teaching of this session, that is alpha. This is direction cosine. This is the angle of the position vector with the x-axis. So if I describe the position vector and find the alpha, alpha is the same as theta. Everyone follows that? This okay. So either way, you can test. You should get the same answer. So starting with AB, I suggest this path. First, I go from A to O, and then from O underneath B in Y direction, and eventually we go vertically up to point B. So that is AB is 2 minus 2i. Everyone can see why minus? Because we're going opposite to x. Minus 2i, and then that is 1j in the positive direction, and finally 2k. We're going in positive k. All right. And what is the unit vector of that? You have to normalize it. To normalize, first, let's find out the magnitude of AB. That is root 4 plus 1 plus 4, which is 3, right? So easy. AB, or unit vector of AB, that is minus 2/3 I plus 1/3 J plus 2/3 K. And cos alpha is minus 2/3. So here you find out the. Okay, so let's run 220. Okay, we already did that. All right, next question. Now we want to use that unit vector to describe the force. I don't think it had anything new in it. You already know what that means. The reason we were interested in unit vector was not because of the position vector. We wanted this to describe the force vector. Okay, so let's do this. And then the point is, yes, the very same unit vector is shared between the position and the force. So here, I give you 2 minutes. Try this yourself, and then we do that together. So this guy is exerting a force of how much? What is the magnitude of the force they apply? Or which page was it? Where did I get it from? Oh, that was from the slide. Yeah, okay. They are exerting 350 Newton.
I have to find AB first, right?
You have to
Find the AB first.
AB, yes. AB, you have to find AB first. And this guy is pulling toward himself. So that gives you a sense of what is the direction of the force. Okay, it's a cable, only works under tension. To put that in tension, it means you need AB, not BA. Okay, so you have to go from A to B. How do you go from A to B? I suggest we do it this way. Go from A vertically down in negative direction, and then we travel along the positive x, and finally we travel in the negative j. So AB, let's start with AB. That is 3i minus 2j and minus 7.5, take away 1.5 because this is not level with the ground.
Yes.
Okay, so
7.5 minus
6, yeah. that is 6 minus 6k. And then what is the magnitude of AB? That is 9 plus 4 plus 36, and that is 7. Yep. So therefore, your unit vector of AB, which is the same as unit vector of F, right? So this is a very important equation. They share the same unit vector. That is 3 over 7I minus 2 over 7J minus 6 over 7K.
So what you say, what you're trying to say with F is force. F means force.
The unit?
Unit of force, right?
Yes, yes. So position unit vector does not have unit vector is in meter, I think. That should be the same with or maybe it doesn't have a unit. The unit is for position vector. Position vector is in meter, but the unit vector is like IJK. It doesn't have a unit. All right, so the next thing is, how do I express force as a vector? So the force as a vector, that is the magnitude of the force by its unit vector, right? And that is 350 divided by 7.
And then multiply.
I think that's 6, is it? 50. Okay, so that is, yes, the formula. The formula is the vector, force vector, is equal to the magnitude of F multiplied by the unit vector of F. So magnitude of F, we already know what is the magnitude of F. This is 350. So that divided by 7 is 50. So 50 times 3, that's 150 I minus 100 J minus 300 K. So now you can test that this magnitude should become 350. You can calculate this magnitude. It should give you 350. How do you find the magnitude of F? That is root 150 squared, 100 squared, 300 squared. That should become 350.
And so we can check that.
You can check it, yeah. All right, the next topic is, you know how to project a vector along the XYZ. But now the question is, what if you want to project a vector over another vector? All right, so there are two vectors, and you want to find the projection of one along the another one. This is a typical application of the dot product. From calculus, we remember if two vectors are multiplied in a scalar fashion, that is the magnitude of one vector along the other one. All right, so how do we do the dot product? Okay, dot product, there are two formulas depending what you have, you can yeah, well, this is even easier. That's a force vector along a line. This is the very same thing we discussed. So this line and that force, they are sharing their the same unit vector. That's how. So let's now put this to another level. In this case, I want to add these two forces together, but the forces are three-dimensional. So first, I need to find out each force ijk component, and then combine the I components together, combine Z components, Y components together. Okay, so that is very routine. We just do this through the solution here. So first, you need to find the position vector of AB, and AB, the way they did it is the coordinate of the tail minus the end. I mean, you could do that with choosing a travel plan. I mean, I would take from A to the origin and from origin to B. And for second one, I go from A to the origin, from origin to this side, and 2 meter positive Y and 4 meter positive I. Okay, eventually you find the position vector of AB, and from AB you find the unit vector, and that unit vector you can use it to describe force AB as a vector. The magnitude is 100. You can do the same thing with force AC. The magnitude is 120, and then that is just to combine them together. Let's go to page 76. Okay, 27.
Thank you. Number 76.
2-7, fundamental problem 2-7, page 76. Okay, so this problem, I mean, it would be much easier if you add proper label to this illustration. The illustration doesn't have proper label. So what I do is I put A, B here, point A, point B. So let's find out AB first. And for that, you can go 1 meter negative Z, and then you can go 2 meters along the positive Y, and then minus 1 meter, minus 2 meter in X. So that is minus 2I, positive 2J, and negative K. Is that right?
Yes.
Okay. And what is the magnitude of AB? 4, 4, 1, that is 3. Okay. So unit vector of AB is the same as unit vector of F. That is minus 2/3 I plus 2/3 J minus 1/3 K.
Shouldn't it be 2i?
2I?
Yeah, this one.
Well,
minus 1.
no, you go in the opposite direction of X. Positive direction of X is like that. So going from here to there, you go in the negative direction of Y. Okay, so now just 300 would cancel with that. So the force vector is magnitude of force, which is 300. Well, with the k you go down because it's opposite to the z direction. Positive z is that way, so you are going down. So that is why you put minus k. Well, look, is this going down or up? I mean, the first move, the vertical. I'm moving in this direction, right? I'm moving in this direction. But the positive is opposite. Positive is up. This is positive z. You go to the negative z. So that's why minus k. Yes? All right, sure. So that is magnitude of the f multiplied by unit vector of f. And that is minus 200i plus 200j and minus 100k. So how can you test this answer? Nguyen, how do you test this result? How can I assure this answer is correct? Can you find the magnitude of this force? And that should be what? That should be 350. Because the magnitude should be 300. So if I do magnitude of this force, that is 200 squared plus 200 squared plus 100 squared. So if you solve that, that should be 300. Yes, that's one way of testing your solution, testing your answer. Questions? Any questions? Am I going too fast? All right, so page 77. And this time 21 to 24. Okay, so you choose and I try to solve. From 21 to 24. You want simple, medium, difficult.
So I wanted to do this.
21 to 24. Simple, medium, difficult. 40. Difficult. Oh, yes, that's good. That's what the teacher wants to hear. No, kidding. I'm here to listen to everyone.
So do we have like any answer sheet so that we can, if we solve this problem in our home, we can just take our answer sheet, like
Yeah,
try to do. Do we have any like answer sheet?
these are enough. In my day, Shah, there were no internet, and we had to do all the questions from the textbooks, and then it was a library, and library had three different titles by three different authors, different problems. People who wanted the perfect score, they went to the library, and then the chance was my teacher put the key textbook out of the access. And even though if we did all the questions in this, you were taken by surprise in exam. So you're lucky. You're living in an age with a kind teachers, yeah, not wicked teachers. All right. So here we want to find the resultant, and that is very um, cumbersome. You have to find each of the forces and then finally add them together. But there is nothing complex, nothing difficult about it.
You can separate the A, B, and C.
Yes. So ABAC, how do we do ABAC? That is from A to B. I go So that is AB, which is so 3 take away from 1, that is minus 2k, and x, that is minus I, and in j direction that is positive 2. And what about AC? AC, let's choose a different color. So first is a little one here.
There is control group, right?
Yes.
3 minutes.
Okay, so that is for AC. AC, that is 3 meter, 2 meter minus k. And in the x direction, that is 1 meter, 2 meter minus 3 I. And in the j direction, that is 1.5 positive. Okay, and then the magnitude of AB, magnitude of AC. Could someone with a calculator help me? That is 144. This is 3, right?
Yeah.
And what about this one? That is this is 632. 36, 4, 4, and that's root 13. What is that? 3.5. Yes. Okay. So therefore, the unit vector of AB, which is the unit vector of FB, that is minus 1/3 I plus 2/3 J minus 2/3 K. And the unit vector of AC, which is the unit vector of FC, that is minus 3 by 3.5 I plus 1.5 by 3.5 J minus 1 by 3.5 K. Okay, and then all you have to do, you have the magnitude of the forces. So FB is magnitude of FB multiplied by unit vector of FB, which is 3 kilonewton multiplied by and then we have FC is equal to the magnitude of FC multiplied by the unit vector of FC, which is 2.45 multiplied by and then all you have to do is add the similar terms. I is together, J is together, case together. Unit, the unit is the same as kilonewton. Yes, the unit is kilonewton.
Should it be 3,000 instead of 3?
No, if you leave it as 3, then put a kilonewton in front of it. So that is how you say it. But if the problem asks you to express the answer in Newton, yes, multiply by 1,000. Now this is in terms of kilonewton.
Now it seems like very simple. If we could do like for A and B, and then B to A is very complex.
I think I agree with you. Some people prefer other way. I
But it's
think
easier.
this way is easier. When you get used to it, you find this very easy. You construct what you need just on the spot. All right, let's go back to okay. We have, yeah, 40 just asked for the most difficult one, so there is no room for going back to medium or simple. Anyone objects 40? You want me to go back to the simple? I'm happy to do something simple. The final answer. Oh, I haven't added them together yet. I left this for you to add them. So all you do is you simplify that, add I components together, J components, K components together. It only asks for the resultant. So the resultant is FB plus FC, and that is just you collect the similar terms together. Anyone wants me to go back to something simple or medium?
What about the 21?
2-1. Let me see how many slides I have. I take my word back. We have too many slides. Yeah, look. So all these things should be. Oh my God. All right. So let us move on to the application of dot product. So dot product is a convenient way of finding or projecting one vector over another vector. How do you do dot product? There are two ways of doing that. If I'm given the angle between the vectors, the easiest way is just magnitude of this, multiply magnitude of that, multiply by cos theta. But the chances are, like the previous sample, you don't have angle between them. So what do? You multiply the similar terms and add them together. So two formulas should give you the same answer depending what you are being provided with. So you decide which formula you use. So let me summarize two formulas for you. So if I have AXI, AYJ, AZK, and BXI, BYJ, BZK. So how do I find A dot B? In this case, A dot B is simply AX BX plus AY BY plus AZ BZ. Or if these vectors are provided by their magnitude and the angle between them. So what you do is A dot B is magnitude of A multiplied by magnitude of B dot cos theta. And then what this represents? This represents the projection of this one over that. And what is the nature of that? The nature is a scalar. It's not a vector. It's a number. The next question is, if you have the projection over that, how do you find the component perpendicular to that? So this is simply a Pythagoras theorem. So you know how to find parallel to a vector. So what would be the projection of this one normal to that vector? So all you have to do is the entire vector squared minus this one squared, take a root, and that give you the component normal. So we are using notations like parallel. Parallel is the dot product, and the a normal. A normal is that component which makes this a right triangle. All right, here we want to do the projections. So let's do this example. This frame, the force is provided as a vector. It is along the y-axis, so this doesn't have any I component, any j component, and any k component, only j. And you want to find its component parallel and perpendicular to AB. Okay, so that's interesting. So first you have to construct AB, and everyone knows how to construct AB. So how do you go from A to B? You go from here to here, and just you come from here to here, here, and there. That is AB. That is 6K, 2I, and 3K. That is AB. So you construct AB, and then doing the dot products of F multiplied by AB, that give you the component parallel. The component perpendicular to that is this one squared minus that one squared, take a root. So the entire solution is here. Next one.
Solve that one, the previous one.
The
previous one, could you do it yourself? So I can.
This one?
Yes.
Okay. So AB, I construct AB for you. Okay, F is 300J, and you want to find AB. With AB, I go in this direction, and then I come here, and eventually I go there. So how do I write AB? That is 2I, and then 2J, or 6J, and finally K. Okay, so that's AB. Now you want to project this one along this one. So we multiply that by the unit vector of AB. What is the unit vector of AB? So magnitude of AB is 4, 36, 9, 7. Yeah. So the unit vector of AB, that is 2 over 7I, 6 over 7J, 3 over 7K. Okay. So now if you multiply this, that is 7 multiplied by 0 plus 300 times 6 over 7 plus 3 over 7 multiplied by 0. All right, so only that term is the projection. And then finally, you want to find, this is the parallel. This is F parallel to AB. So how do you find F normal to AB? That is 300 squared minus that 306/7 squared. It's a right angle you solve. So this is something like that. AB F. So that is F parallel, and this is F normal.
So there is no force in x and z axis, right?
No, only along the y direction.
Can you repeat the last part? The last thing.
The last one, I think that best is if you watch this slide. Okay, so you have a vector and you want to project it along a unit vector. All right, so that is the vector itself. How do you find the projection which is parallel? So you multiply that vector by this
I
unit
understand
line.
that, but how did you make it that direction?
Yes. So this is the one normal. This is the one parallel.
I know that.
Yes.
The one that you did in that, the question.
In this
over
one?
here, how did you find the F, the coordinate, the line that you made? When you extend the lines?
You want to see this graphically?
Yeah.
Okay, graphically, this is a three-dimensional, and that is parallel to Z. So that is the angle between them, theta. So you just make a projection. That projection is three-dimensional. It's difficult to show it here, but if you watch it from the plane which contains that line and the force itself, that becomes a triangle, a right triangle. With that right triangle, what we found was we found the adjacent. So you want to find the opposite term. This is the hypotenuse. The force itself is the hypotenuse. This is adjacent, this is opposite. So that is follows the Pythagoras theorem.
Which one are we supposed to find?
Yeah, with that Pythagoras theorem, this is the force itself. This is F. This is the one parallel. Adjacent is parallel.
The upper one where you made it up.
So this is the parallel, and this is the perpendicular, and that's the force itself.
Could you extend the last line? You did last line.
Last line, this one.
Yeah, at the last line.
What is wrong with
Yeah,
that?
root over 300 square minus 6 by 6 by 6 by 6.
By 7. Yeah, by 7. Yeah, you're right. 6 or 7. That is the adjacent. That's the hypotenuse.
But we are getting the need force there, right?
Yes. All right. Two last steps. Okay. The first step is you have a vector force which is parallel to the y-axis, and then you have a direction which is along the AB. How can you project force along that AB? The answer is you find the unit vector of AB and dot product F as a vector by unit vector. So that gives you the component of F parallel to that direction. And then the second question is, what is the component normal to that direction? So to find that normal, you have to construct a right triangle with the force itself being hypotenuse, the one parallel being the adjacent term, and the component which is perpendicular being the opposite side of the triangle. All right, so maybe you just slides are available from Canvas. I suggest go through these. These are summary. We have to go fast, otherwise we cannot finish. Sorry about that. And still, if you can explain it, just come and see me during the consult. I'm happy to take these for you. So we have Yeah, 10 slide, and then we have to finish. Yes, that is Tuesdays, 10:30 to 12:30. I'm in a student hub. Make sure you can see me there, all right? All right, next problem. Here you have a force 800 Newton, and you want to find the angle between these two. So that is interesting. Um, okay, anyone can explain to me what is the steps? If I want to find theta, what are the steps?
You have to find AB, then AB and AC.
Mm-hmm. Okay, what about this one? If I write um,
Then AC cos theta.
if I write A or BA dot product by BC, that is magnitude of BA multiplied by magnitude of BC multiplied by cos theta, correct? So from here, I can say cos theta is dot product BA BC divided by the product of magnitudes. So yes, let's find them one by one. How do I find BA? BA. Okay, we want to find BA. I go 1 units in the positive Z, and then I go 2 in the negative I, and 2 in the negative Y, correct?
Copy AB.
This is BA. BA.
Oh, first, yeah, 1 and 2, then
Yeah. So in terms of X, that is minus 2I. In terms of J, that is minus 2J. And in terms of K, that is plus K. Okay. And what is its magnitude? That is 4413, right? And let's construct BC. BC, you go 1 unit up, and then you go 3 units in the negative Y, correct? And it doesn't have any I component. So that is 0I minus 3J plus K. And then, therefore, its unit vector of BC is 9, 1, 10, is root 10, correct? And now we just substitute this number. But before that, how do I find BABC? You can tell me, how do I find BABC? These are just term by term, right? So that is minus 2 times 0, minus 2 times minus 3, and plus 1 times plus 1. This is 6, this is 7, right? Okay, so now I just plug everything in that equation. Cos theta becomes 7 divided by 3 times root 10. And you find theta from there.
Could you do BA once again?
BA. Okay, BA, there are two ways you can construct BA. First, you write the coordinate of B, coordinate of A, and then you take the coordinate of the last one minus the coordinate of the first one. Directly is you can go travel from B to A. You travel from B to A just using the coordinate directions. So first I go up in 1 unit, that's 1k. Then I go 2 units in the negative x direction, this is minus 2j, minus 2i, and then I go minus 2 in the j direction.
Okay, it's one.
Yeah. BC? BC doesn't have I because it rests in the ZY plane. That's my understanding from this figure. Can you see the same thing? To go from B to C, it seems to me B and C, both of them are in the same plane. They don't have any different x values. So both B and C, their x component is 2 meters. So 2 minus 2 is 0. So 0 I. Questions?
So even though the vectors have I, J, A, don't keep them there for when you do the ABC?
Why do we need ABC?
No, like in the last step before you get actual cos theta, you're taking the unit vector of BA and the unit vector of BC, don't keep I, J, A in the equation.
Well, to find theta, what we did was we described vector of AB, we described BA, we described BC, and then from that formula, you have to construct BA, BC dot product, then put that in a numerator, and the magnitudes multiplied at the denominator. Yeah, once you add them, it becomes scalar. No IJK anymore. Because of the dot product, the outcome is a scalar. It's not a vector. Okay, the next thing is you want to find the projection of F parallel and perpendicular to BA. So how do we do that? Well, first you have to write F as a vector. How do I write F as a vector? Let's write F as a vector. So F and BC, they share the same unit vector. We agree? So let's find the unit vector of BC. Did we? No, the unit vector we didn't. The unit vector of BC, which is the unit vector of F, that is BC divided by its magnitude. So that is minus 3 over root 10 J plus 1 over root 10 K, correct? And now all you have to do is that magnitude multiplied by this one. So F as a vector is 3 times 800, that is 2400 over root 10 negative J plus 1 over, oh, sorry, 800 over root 10 k. So that is what f is. And okay, so I also need to find the unit vector of BA. So unit vector of BA, that is minus 2/3 I minus 2/3 J plus 1/3 K. Okay, now let's dot product F by UAB. So the next thing is you have to find dot product of F by UBA. And that gives me what? That gives me the component parallel to BA. Parallel to BA. That is going to be minus 2/3 multiplied by 0. This doesn't have a, F doesn't have I component. Plus or minus 2400 root 10 multiplied by minus 2/3, correct? And finally, plus 800 by root 10 multiplied by 1 over 3. This is not a perpendicular, this is a parallel. When you do the dot product give you parallel to BA, and then to find the perpendicular, you just solve the Pythagoras triangle.
This last part.
I do,
This you,
yes,
give me that again.
the U.
You.
Okay, so the unit vector of BA, that is equal to unit vector of BA. How do we find it? This is BA itself divided by the magnitude of BA. So we already have BA, and the magnitude of that was 3. So we divided the vector by its magnitude, that was the unit vector.
Can you explain the parallel to BA? What does that mean?
Which one?
Parallel to BA.
Parallel to BA. So this one, this is F, right? And that is BA, right? So first you have to project this one over this one. That is theta. That is the one which is parallel. This is parallel to BA. This part, right? And then the normal is this one. That is the hypotenuse. This is F itself. This is the BA. That's the one which is parallel to BA. This is the one which is normal to BA. So eventually you will have something like this. This is F. This is BA. So BA, I mean, that's BA. This is the unit vector of BA. So you multiply that by unit vector of BA. That is the one which is parallel to BA. F parallel to BA. And this is F normal to BA. And that is BA. This is unit vector of BA.
Sorry, but I'm a little confused. If we do this same thing on this diagram, it kind of doesn't make sense to me. Can you do it on the diagram?
With the diagram, okay. In this diagram,
On the diagram.
on the diagram. All right. So this is BA. And what is the unit vector of BA? The unit vector of BA would be something parallel to that, smaller than unit, right? And then when I make a projection from this force over here, that is a right triangle. So let me zoom in here.
But if we make it parallel to BA, it's a bit tilted towards the middle.
Why? No. This is parallel to BA. This is parallel to BA. That is 100% parallel to BA. Once you project F over BA, that is the adjacent term. This is the opposite term. And look, this is a right triangle. In this right triangle,
That is what we're
this is the 90 degrees. That's the hypotenuse. This is the one which is parallel to BA. This is the one which is normal to BA. That is normal to BA. This is parallel to BA.
but it looks tilted. The vector BA looks a bit tilted.
Well, yes, that is true. I mean, we are not talking about IJK. We are talking about BA in the 3 dimension. It's tilted. That's the complexity. That's why we use the dot product. Otherwise, why should you bother? I mean, you make a triangle and calculate everything. The main reason we go for dot product because it's tilted in the 3 dimension, difficult to visualize. So you cannot do this by eye. But if you write this as a vector, write that one as a vector, no way you can go wrong. But if you try to visualize it, yes, I agree. Sometimes it's confusing.
It's over there, but
Yes, sometimes confusing. Yeah, that's why.
why the sculpture line?
Because this is the 90 degrees angle. Once you project from here, right? That's a meaning. Look, I have a line, I have a point. I want to project from here to there. The projection means when I project this end, the foot is normal. So I projected from here to here. That means this angle is 90 degrees. When it is 90 degrees, this is parallel to BA. Yes, that's BA. That's a portion of BA. Should be parallel to it. So this is BA. A portion of this is parallel to BA, isn't it? And then the next one, the next side of the right angle, this is the one which is parallel. This is the one which is normal. Okay. Yeah, that has been shown also here. Look, the only difference here is that normal is equal to this normal. So this is a parallelogram. It won't make a difference either you look at this way or that way. So this is the same. This is the normal, this is the parallel. Okay, page 86. All right. Simple, medium, difficult. Maybe this is democracy. Those on simple, hands up. Medium, hands up. Difficult, hands up. So that's medium. So let's go for medium. It's either B or, yeah, well, 2829. Okay, so you want to find the projection of F over AA axis. AA is a 3-dimensional axis. Yes, Serish, I agree. This is confusing. It's difficult to visualize. That's why we are using Cartesian coordinate, because this has nothing to do with my imagination or your imagination. That you can't go wrong if you follow the procedures. Graphics is only a way of helping you to understand. It's okay if you can visualize it, but if you just follow the steps, that's so here we have a force which is three-dimensional. We have a direction which is three-dimensional. Not very easy to visualize. I mean, in has all three components ijk's in it. So how do I write f? So first I need a unit vector for f. So that unit vector, I call this point, let me label this point as a, b, right? So we want to go from A to B. So watch me, how do I go from here? That is first 2 meters along the positive y, and then 2 meters along the positive x, and finally minus 1 meter in z direction. Okay, AB, that is 2j, 2i, and minus k. Does that make sense to everyone? Yes? All right. So the next step is I need to find this unit vector. How do I find this unit vector? So the unit vector of AB, which is the same unit vector as of F, that is AB itself divided by its magnitude. So that, what is the magnitude of AB? Magnitude of AB, 3. So that is 2/3 I, 2/3 J, minus 1/3 K. Who is with me? Yes, you follow this one? Okay. And what is the next step? The next step is I need to do the same thing for AA. I need to find the direction of AA. So how do I do that? To go from A to A, you first go 2 meters along the positive y, and then you go minus 1.5 meter along the x-axis. So AA, that is minus 1.5 I plus 2j. So what is the magnitude of AA? That's 1.5 squared plus 4. Yes, 2.5. So therefore, the unit vector of AA, that is all right. So the next step is how do I write force F as a vector? So force F, that is magnitude of F multiplied by its unit vector of F. The magnitude is 300 and its unit vector is the unit vector of AA, sorry. All right, so eventually what you get is fxi, perhaps minus, plus Fyj. That's what you get. I didn't simplify that, just leave it to you. And then now you have a force in 3 dimension. How do you project it over AA? You simply dot product it by the unit vector of AA. So that is F parallel to AA. That is equal to F dot product by unit vector of AA. Yes?
There is a unit vector A3 equal unit vector F.
Yeah. Oh, yes, yes, you're right. I made a mistake. Well done, Chesa. This unit vector of F is not that of AA. This is AB. Thank you, Chesa. That is the unit vector of AB. You are correct. Yes, thank you for that.
The question just says the magnitude of the position of force F along A.
Yeah, notation maybe the notation is correct. This notation is correct, but when I try to find F, that is
Unit vector of AA.
oh yeah. Is this right now? Okay, so in that case, I think we can simplify that easily. So this is equal to 200I, 200J minus 100K, correct? Okay, now the next step is that has to be dot producted by the unit vector of AA, which is the unit vector of AA we found it. Okay, so how do I dot product this? This is not like a 2 parentheses multiplied by, I mean, you could just not finding the difference. That dot product are the dot product of the similar terms. So the first parenthesis doesn't have the K component. So this is 200 times minus 1.5 by 2.5 plus the second one is 200 times 2 by 2.5, and the last one is minus 100 times 0 because it doesn't have a K component here. So that is a number. Whatever that number is, this is the force parallel to AA, projected parallel to AA. And how do you find force normal to AA? That is the magnitude of the force, which is 30. It is 30 or 300? Yeah, 300. So that is 300 squared minus F parallel to AA squared, whatever that is. I leave it to you for calculation. Okay, so that was a let me just complete the attendance and then we summarize today's class.
One question, can you move to the picture?
This one, yeah.
Just from the first class into the picture, can we identify which one that parallel and which one is permitted to the
You want me to do it over here,
no,
right?
like
Yeah.
when we first look at the picture, can we just tell it like which one is parallel and which one is permitted to the
Look,
although we have
this one, you just draw a normal to that. I mean, it's not very easy to show, but let's assume that this is a normal, right? So if this is normal, that is the component which is parallel to AA, and this one is the component which is normal to AA. Yes. So that that is a three-dimensional force F. Okay. So you want to project this over another three-dimensional line. So very difficult to visualize, even though this illustration is good, but then using the formula, you have to find the force as ijk, you have to find the unit vector as ijk, and then uh, the unit vector of AA dot product by that of the force, it gives you the component which is parallel to AA, right? And then to find the normal one, you need to understand that this is AA, this is force, and once you draw a normal, that one is the dot product. This is you find it from the Pythagoras theorem. That being F, this is the parallel, this is the normal. Thursday, yes, I'll be. All right. So Sehrich is here, Natasha is here, Nguyen is here, Chaisal here, Abdullah Enja. Have you seen Abdullah Enja? He keep missing the classes. Daniel, Daniel, Jonathan away. Ahmed is here. Nigel is here. Barnaby is here. Flynn is here. Shaw here. And Porty here. All right. So what we did today, uh, we learned that a force vector can be described using a position vector. So because the force and the position vector, they share the same unit vector. And how do we find the unit vector? Is to find the vector first, divide it by its magnitude, or normalize it. That gives you the unit vector. And that unit vector is to describe the force. And then once we have a couple of forces, we can add them together easily by combining their ij components together. But first, you have to find their unit vectors. And the next topic was when you have a three-dimensional force, a three-dimensional direction, how do you project that force over that three-dimensional direction? This is by dot product. So it is easy to understand the component along that line. Naturally, that will be parallel to that. But the one which is perpendicular to that is a bit tricky. Just if you cannot visualize it, that's fine. Just take my word, this makes a right triangle with the force being the hypotenuse, the parallel component being the adjacent terms, and the normal being the opposite term. I appreciate it's not always easy to visualize, but if you can't visualize, don't panic. Just follow the triangle. That don't get you wrong. All right. Any questions? We have another class waiting for us. I'm happy to take your question outside. All right. Thanks very much. I really appreciate you coming to class and looking forward to see you in the consultation or sending me email or whatever. Just let me know how can I help you. Thank you.